The study of geometry by algebraic method is called as the coordinate geometry or analytical geometry. Any two mutually perpendicular lines taken together are called as the rectangular axis, or it is also called as the coordinate axis, or it is also called as axis of a coordinate. So the distance of any point from the origin is square root of x square plus y square. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to take very important and the last unit, that is coordinate geometry, or it is also called as analytical geometry. So in this coordinate geometry you are going to study three units. The first one is a coordinate system in a plane, and the second one is the locus, and the third one is the straight lines. Very simple unit and very important for the point of examination. You may expect around 20-22 marks from this unit. Now first let us move to the first concept, that is coordinate system in a plane. Coordinate system in a plane. Now let us know regarding what is meant by analytical geometry or coordinate geometry, why it is called as a coordinate geometry. Now, so analytical geometry or coordinate geometry is a branch of mathematics which deals with the study of geometry through algebra. So that is, René Descartes is a mathematician who combined algebra and geometry to get a new branch, to develop a new branch, that is called analytical geometry, or it is also called as a coordinate geometry. Algebra and geometry combined to get a new branch, that is called a analytical geometry. That means the study of geometry by algebraic method is called as the coordinate geometry or analytical geometry. So coordinate geometry is a branch of mathematics which deals with the study of geometry by algebraic method. Now René Descartes is a mathematician who combined algebra and geometry and developed the new branch, that is called coordinate geometry. So he is a famous French mathematician who introduced the algebraic methods to solve geometrical problems. The entire subject is a progressive development of the basic of a point P x comma y, of a point. Now Descartes established a relation between the basic geometrical concepts of the point with basic algebraic entry number. This relationship is called as the system of a coordinate, that is called a coordinate system. Now next, the plane in which the points are represented by an ordered pair. So a point in the coordinate system is represented by an ordered pair x comma y. This x comma y represents the ordered pair where x coordinate and y x axis as well as a y axis, right? That is, the real numbers unically and conversely is called as the Cartesian plane. So representing a point in a plane x comma y, representing the ordered pair x comma y in a plane, that is called as the Cartesian plane. Now let us know regarding axis of reference. What is meant by axis of reference? Means every ordered pair x comma y of a real number x and y can be represented by a point in a plane with respect to two fixed lines called as the reference axis. So any point, any ordered pair p x comma y be represented in a plane with respect to or with reference to two lines is called as the axis of reference, that is x axis as well as a y axis. Now which may be mutually perpendicular or any may not be perpendicular. If two lines are perpendicular, then the axes are called as a rectangular, otherwise they are called as oblique. So here they may be mutually perpendicular, may not be perpendicular. The points may be mutually perpendicular or may not be perpendicular. Suppose if they are mutually perpendicular, if the two lines are perpendicular to each other, then the axes are called as the rectangular, otherwise they are called as an oblique. They are called as a an oblique. Now let us know regarding the representation of a point in a rectangular coordinate system. How to represent the point p x comma y in a coordinate? Now that is, draw two straight lines x dash o x and y dash o y. two lines. Let us draw two lines. First one is x dash ox and another one is y dash oy intersecting each other at right angles, and let the intersection point is called as the origin. This is O is called as the origin. The point of intersection is the origin. Now x dash ox is called as the x-axis. This is called x-axis, and y dash oy is called as the y-axis. X-axis as well as y-axis. X dash ox is called x-axis, axis of x, and y dash oy is called as the y-axis, and whereas O is called as the origin. So ox, that is x-axis, oy is the y-axis. Now any point p x comma y can be represented as, here x-axis is OM is x-axis and ON is equal to y-axis, OM and ON. So this ON is also equal to PM and OM is also equal to NP. So here OM is equal to x and PM is equal to y. That is called the x-axis and the y-axis, right? So this is how we are going to represent an ordered pair px comma y in a rectangular coordinate system. Now let us know regarding the two, if the two mutually perpendicular lines taken together are called as the rectangular axis, or it is also called as the coordinate axis or the axis of a coordinate. So if any two mutually perpendicular lines taken together, are called as the rectangular axis, or it is also called as the coordinate axis, or it is also called as axis of a coordinate. Now let us consider P any point in the plane. So that is, this is P any point in the plane. Px comma y be any point in the, let us consider Px comma y be any point in the plane. Through P a perpendicular is drawn, PM is drawn perpendicular to y-axis, cutting the x-axis at M, and draw Pn parallel to x-axis, cutting the y-axis at N, as shown like in this figure. That is, Px comma y be any point, PM is drawn perpendicular to x-axis and Pn is drawn perpendicular to y-axis. Then OM is equal to x-axis and PM is equal to y-axis. That is, OM is equal to x and PM is equal to y. Okay. Now let us move to the next concept. Then OM is called the x-coordinate or abscissa. X-coordinate is also called as abscissa. This is very important point. X-coordinate. The x-coordinate is also called as abscissa, and the point P denoted by x, and MP is called as the y-coordinate, or it is also called as the ordinate. The x-coordinate is called as an abscissa and y-coordinate is called as an ordinate of the point Px comma y. Then the point P is completely determined by the ordered pair Px comma y, x-axis and y-axis. X-coordinate is called as an abscissa and y-coordinate is called as an ordinate, and therefore we are going to represent this Px comma y as an x-axis and y-axis, that is called as the abscissa and the ordinate. Now the ordered pair x comma y is the coordinate of the point P, and it is written as Px comma y is a point. So usually the ordered pair x comma y is represented in the rectangular coordinate system by point P x comma y, x coordinate and y coordinate, that is called abscissa and the ordinate. Now move on to the next one. Here the above system of coordinating an ordered pair x comma y with every point in the plane is called as the rectangular Cartesian coordinate system. That means in the above system, the coordinating the point P x comma y along x-axis and y-axis is called as a rectangular coordinate system. The coordinates of the origin is taken as 0, 0. 0, 0 is the coordinate of an x-axis. Any point on the x-axis can be taken as x, 0, since for any point on the x-axis the y-coordinate is 0. So any point on the x-coordinate is taken as x, 0. For x-axis, y-coordinate is 0. So if this is the point, this is x-axis, and the y-axis, the origin 0, 0, x-axis means here on the x-axis y is equal to 0. On the x-axis y is equal to 0, that is for a x-axis. Similarly, for y-axis, any point on the y-axis can be taken as 0, y. So, since for any point on the y-axis, x coordinate is equal to 0. For y-axis, x coordinate is always equal to 0. For x-axis, y coordinate is equal to 0. The abscissa of any point is numerically equal to the distance of the point. The abscissa, that is the abscissa of any point is numerically equal to distance of the point from the y-axis, and the ordinate of any point is numerically equal to the distance of the point from the x-axis. So, here the abscissa of any point is numerically equal to the distance of any point from the y-axis, right? And whereas the ordinate of any point is numerically equal to the distance of any point from the x-axis. One is from x-axis, another one is y-axis distance. Now let us know regarding the quadrants. So, you might have been studied in your trigonometry itself, first quadrant, second quadrant, third quadrant and fourth quadrant. Same concept we are going to study here, first, second, third and fourth quadrant. So, here now let us consider this rectangular coordinate system. So, x dash o x is called an x-axis, y dash o y is called an y-axis. X o y is called a first quadrant, this is called first quadrant, and again x dash o y is called as a second quadrant, x dash o y dash is called as third quadrant, and whereas x o y dash is called as the fourth quadrant. So, x o y, x dash o y, x dash o y dash, x o y dash. So, here the two mutually perpendicular lines x dash o x and y dash o y divides the plane into 4 equal parts as the quadrant. So, this will divide into 4 equal parts, that is called as the quadrant, first, second, third and fourth quadrants. Now, the region x o y is called as the first quadrant, x o y is called as the first quadrant, and similarly the region y o y dash is called as the second quadrant. So, here x o y is called the first quadrant, y o y x dash is called as the second quadrant, and similarly the region x dash o y dash is called as the third quadrant, and last finally y dash o x is called as the fourth quadrant. So, x o y is called first quadrant, y o x dash is the second quadrant, x dash o y dash is the third quadrant, again y dash o x is called as the fourth quadrant. So, these are called as the quadrants. So, first, second, third and fourth quadrant. Now, let us know regarding the signs of these 4 quadrants. Now, if you come to the first quadrant, see this you might have been studied in your previous classes. So, this x-axis is positive, y-axis is also positive, x is positive, y is also positive. So, for x is positive, y is positive in first quadrant. Now, straight away if you move to the opposite of this first quadrant is the third quadrant. In third quadrant, you will get a negative and negative, x is negative as well as y is negative. See, x is negative, y is also negative. So, in third quadrant, both x and y are negative. Whereas, if we come to the second quadrant, in second quadrant, x is negative, whereas y is positive. In second quadrant, this x is negative and y is equal to positive, negative and positive, minus and plus. Whereas, if we come to the fourth quadrant, x is positive, y is negative, opposite to that. So, these two are opposite, plus and plus in first quadrant, minus and minus in third quadrant, minus and plus in the second quadrant, plus and minus in the fourth quadrant. So, in general, in first quadrant, x is positive, y is positive, in second quadrant, x is negative, y is positive, and in third quadrant, x is negative, y is negative, whereas in fourth quadrant, x is positive and y is negative. These are called as the signs, rectangular coordinate system, signs of the point p x comma y in the rectangular coordinate, that is called rectangular coordinate system. Let us know regarding in general, in quadrant, first, second, third, fourth quadrant, in x coordinate and y coordinate. In first quadrant, both are positive, plus and plus. X is positive, y is positive. In second quadrant, x is negative, y is positive, minus and plus. In third quadrant, both are negative, minus and minus. X is negative, y is negative. And in fourth quadrant, x is positive, y is negative. These are the signs of a rectangular coordinate system. Plus and plus, minus and plus, minus and minus, plus and minus. That's it. Okay. Now, By knowing this, let us move on to the reflection or image of a point with respect to x-axis and y-axis. This is a very important concept. So, reflection. Here, to find the image of a point A, 1, 2 in the x-axis, produce AM to A dash, produce this AM to A dash, up to A dash, such that M into A dash is equal to 2, MA dash is equal to 2 units here. So, let us represent the point A 1, 2 in the rectangular coordinate system. X-axis is 1, y-axis is 2, OM is equal to 1, AM is equal to 2. Now, to find the image or reflection of the point A 1, 2, produce this. This is produced, that is, produce AM to A dash, such that M into A dash is equal to 2 units, right. Now, we can arrive at the point A dash is equal to 1, minus 2, which is the image of A in the x-axis. The image of A on the x-axis is A, that is 1, minus 2. This x-axis is same, whereas the value of 2 is minus 2 in the fourth quadrant. So, that is the image of A 1, 2 is A, minus 2, right. Now, similarly, to find the image of the point A 1, 2 in the y-axis. So, if you want to find the image of A on the y-axis, so produce AN to B dash, produce this AN to B dash, such that the distance from N to B dash is equal to NB dash is equal to 1 unit. So, therefore, we can write B dash is equal to, in opposite direction, it is minus 1, 2. Therefore, the reflection or the image of the point A in y-axis is nothing but minus 1, 2. That means, the image or the reflection of the point A 1, 2 on the x-axis is 1, minus 2. Similarly, the reflection of the point A 1, 2 on the y-axis is minus 1, 2. So, for x-axis 1, minus 2, for y-axis minus 1, 2. So, the opposite, this x-axis will remains the same, whereas y-axis it is opposite direction. One is positive, another one is negative. Therefore, you will get the reflection of A 1, 2 on the x-axis as 1, minus 2. Whereas, if we come to the second part, the reflection of the same point on the y-axis. In the y-axis, the value of y remains the same, whereas x changes, x is towards the negative direction. So, therefore, minus 1, 2 is the image, that is the reflection. That's it. Okay. Now, so that means when a point is reflected in the x-axis, the sign of its ordinate changes. When a point is reflected in the x-axis, the sign of its ordinate changes. So, reflection of a point in the origin. Suppose when a point P x, y is reflected in the origin, the signs of abscissa and the ordinates both changes. When a point P x, y is reflected in the origin, the signs of its abscissa and the ordinate both will changes. That's it. Now, let us move on to the problems. Now, mark the point 2, 3, minus 3, 2 and minus 3, minus 2 in the rectangular coordinate system. This is a very simple concept. Now, let us mark this point in the rectangular coordinate system. Before that, you know this in the first quadrant, second quadrant, third quadrant, fourth quadrant. In first quadrant, x is positive, y is positive. In the third quadrant, x is negative, y is negative. In the second quadrant, x is negative, y is positive. In the fourth quadrant, x is positive, y is negative. If you know this concept, you can usually write. Now, let us write this is x-axis x dash O, this is y-axis y dash and x dash. Now, let us take each unit is equal to 1 centimeter. 1, 2, 3, 4, 5. 1, 2, 3, 4 and 5. Here it is minus 1, minus 2, minus 3, minus 4. This is plus 1, plus 2, plus 3, plus 4, plus 5. Again this is minus 1, minus 2, minus 3, minus 4 and minus 5. So, let us take scale 1 unit is equal to 1 centimeter. Now, first point 2 comma 3, x is positive, y is positive comes in the first quadrant. So x is 2, y is 3. So 2 comma 3 comes here. This is the point, that is call it as A, 2 comma 3. So x is 2 and y is equal to 3. This is the point A 2 comma 3, right? A 2 comma 3. Next B, what is B? Minus 3 comma 2, x is negative, x is negative, y is positive comes in the second quadrant. See, x is minus 1, minus 2, minus 3 and y is equal to positive, plus 1, plus 2. This is the point. So this is B, let us call it as B, minus 3 comma 2. So x is negative, plus 1, plus 1, minus 1, minus 2, minus 3, plus 1, plus 2, minus 3 comma 2 in the second quadrant. Whereas if we come to this, minus 3 comma minus 2, minus 3 comma minus 2 means both are negative, comes in the third quadrant. In third quadrant, this is the third quadrant, both x is negative and y is negative. X is equal to minus 3, minus 1, minus 2, minus 3, y is equal to plus 2. So this is the point, that is nothing but call it as C, x is minus 3 and plus 2. Now let us consider one more point, let D another point, call it as a plus 3 comma minus 4. Now where we are going to represent plus and minus comes in the fourth quadrant. In fourth quadrant, x is positive 1, 2, 3 and y is negative 1, 2, 3, minus 4. So here we are going to get, let us call it as D. D is equal to 3 comma minus 4. This is how we are going to represent a point in a rectangular coordinate system. Once if you know this signs of a coordinate system, then it is very easy for you to represent the point on a line. Next, now plot the point 2 comma 3, 3 comma minus 4, 0 comma 5 and minus 1 comma 4 on the coordinate plane, same as that of the previous one. Let us draw this. This is x axis, y axis, x dash and y dash. This is origin. Now let us take it as 1, 2, 3, 4, 5, 6 plus, and these are all negative values and these are all the negative values. First let us call it as A 2 comma 3, x is positive, y is positive, x is positive, y is positive, 2 comma 3 comes in the first quadrant, call it as 2 comma 3. And the second, x is positive, y is negative, x is positive, y is negative comes in which quadrant? See here, x is negative, x is negative, x is negative and y is positive. So here x is positive means it comes in the fourth quadrant, x is positive, y is negative, x is equal to plus 3, 1, 2, 3 and y is negative, minus 1, minus 2, minus 3, minus 4. So this is the point, call it as B. B is 3 comma minus 4, x is plus 3, y is equal to minus 4. Now come to 0 comma 5, right? Now x is 0, so x is 0 here, and what is y? Y is equal to 5. So 1, 2, 3, 4, 5. This is, call it as C, 0 comma 5, 0 comma 5, that is 0 comma 5. This is y axis. So in y axis x coordinate is 0. Next, minus 1 comma 4, x is minus 1, y is equal to plus 4. Minus 1 comma 4 comes in second quadrant. See, x is negative, y is positive means it will comes in this direction, minus 1 comma, this is x is minus 1, y is 4, 1, 2, 3, 4. So this is the point. This is nothing but call it as D, minus 1 comma 4. That's it. So x is positive, y is positive, 2 comma 3. So here x is negative, y is positive, minus 1 comma 4, x is positive, y is negative, 3 comma minus 4 and x is 0, y is equal to 5, right? Suppose, let us call it as, for example, yes, E. Let us consider 4 comma 0. X is 4, y is 0. That means x is 4. 1, 2, 3, 4. Y is equal to 0 means we will get this point. Call it as E. 4 comma 0. That's it. Okay. This is how we are going to represent. Now move on to the next one. Now we have, this is one more simple question. Find in which quadrant the following lies. So 9 comma 8 both are positive. So both are positive means this is in first quadrant. In first quadrant both are positive. Now, you know this, in first quadrant x is positive, y is positive. In third quadrant x is negative, y is negative. In second quadrant x is negative, y is positive. In fourth quadrant x is positive, y is negative. First quadrant, second quadrant, third quadrant and fourth quadrant. So both are positive, it is in first quadrant. So x is positive, y is negative. This is positive and negative, means this is in fourth quadrant. This is in fourth quadrant. X is negative, y is also negative, that is in x is negative, y is negative is in third quadrant. That's also first quadrant, fourth quadrant and the third quadrant. Similarly, what are the coordinates of the following point? Yes, what are the distance of the following point from the coordinate axis? Now we have to find the distance for this, right? Let us know regarding the distance of any point. Suppose let p x comma y be any point, that is here this is x axis and y axis. Let p x comma y be any point. Now let us join this point. Now here OM is called x axis, this is M, and ON is called y axis, this is N. This is equal to x. Now join this is OP, and join this point OP. So this is PM and PN. So here OM is equal to x, OM is equal to x, OM is equal to x coordinate, ON is equal to y coordinate of this point. Now if I observe carefully, this is how the form, a right angle triangle. You can apply the Pythagoras theorem for this. From this triangle, OP can be written as OP square is equal to OM square plus MP square. What is this? Is nothing but OM is equal to x square plus MP is also equal to y square. So therefore the distance OP is equal to root of x square plus y square. That means the distance of any point from the origin is square root of x square plus y square. So if you put root of x square plus y square, you will get the distance of a point from the origin. So this is called as the distance formula. So the first distance formula is distance formula. So the distance of any point from the origin is square root of x square plus y square. Now let us come to this. What are the distance of the following from the coordinate axis? Now the distance of the point from the origin here is, so here let us call it as x comma y. So the distance OP is equal to square root of x square plus y square. So what is this equal to? Root of 3 square is 9, 4 square is 16, that's equal to root 25, that's equal to 5 units. The distance is 5 units. Okay. Now move on to the next one. The distance of the point here also, this is x coordinate and y coordinate. OP is equal to root of 8 square, 8 is 64 plus 7 sevens are 49. So what is this equal to? Square root of 9 plus 4 is 3. 6 plus 4, 10 plus 1 is 11, 113. Right. Now let us take this. Here also let us call it as the distance from minus 6 comma minus 6. That is x is minus 6, y is also minus 6. Minus 6 square is plus 36 plus 36, that's equal to root of 72. 72 can be written as 36 into 2. 36 into 2 means this is nothing but 6 root 2 units. That is the distance. Okay. Now move on to the next concept. Now find the coordinates of the reflection. What is to find is the reflection of the point with respect to x-axis, y-axis and the origin. Now the reflection of this with respect to x-axis. With respect to x-axis, this is 2 comma minus 4. Right, 2 comma minus 4. Now similarly with respect to y-axis, the reflection with respect to y-axis is minus 2 comma plus 4. See, the reflection with respect to x-axis is 2 comma minus 4 and with respect to y-axis is minus 2 comma 4. Now with respect to the origin, now the reflection with respect to origin is, with respect to origin, the reflection is minus 2 comma minus 4. That's it. Right. Now let us take next problem. With respect to x-axis, y-axis and the origin. So with respect to x-axis, the reflection of, with respect to x-axis, the reflection of minus 3 comma plus 5, minus 3 comma plus 5 is minus 3 as it is minus 5, minus 3 comma minus 5. Okay. Now with respect to y-axis, the reflection with respect to y-axis is just change the sign for x coordinate. So this is minus of minus is plus 3 comma plus 5, plus 3 comma plus 5. So with respect to x-axis, the reflection is minus 3 comma minus 5. We are changing the sign for y-axis. With respect to y-axis, just change the sign for x-axis. Minus into minus becomes plus 3 comma 5. So with respect to origin, so just change the sign for both. Minus of minus becomes plus 3 comma minus 5. That's it. This is the reflection with respect to the origin. This is how we are going to write the reflection for this given point with respect to x-axis, y-axis and the origin. Hope you followed. So that's all regarding today's session. Let us meet with the different concept in the next session. Thank you very much.